Hello everyone, I am Lakshmi Narayana, the team lead for Team DeHaRT, and this is our solution for problem statement 1417 of SIH 2023. Indoor fire accidents usually result in buildup of huge amount of smoke, and the smoke settles down, and by the time the fire brigade comes in for rescue, they are left with poor visibility. Imagine only if they had the advantage of seeing through the haze. This is where our solution comes in. We have collected the ideal data set and have trained the perfect neural network model to perform dehazing in real time, and that is what DeHaRT stands for. And the neural network architecture we are using is a fairly simple encoder-decoder architecture with a couple of skip connections, which fairly resembles the famous unit architecture both in structure and efficiency. The encoder block consists of 4 convolutional layers of multiple filters each of all size 3x3, and it uses radio activation function throughout the block. The input image, as it passes through the encoder block, gets downsampled by the convolution operation. By the time it reaches the center of the architecture, it is converted into a low-dimensional representation, also known as latent space representation, which is then fed into the decoder block consisting of conv 2D transpose layers, which perform the operation of inverse convolution. That is, they upsample the low-dimensional representation of the input image. This task of downsampling and upsampling, along with convolution and inverse convolution operation, itself will dehaze the input image. The skip connections are very important in this architecture. Firstly, they are helpful in mitigating the problem of exploding gradients during the back propagation step and gradient descent step. Secondly, they are helpful in retaining the structure of the input image. We are training this architecture using ADAM optimizer, the adaptive movement optimizer, and we are using custom laws which we have defined ourselves. We have trained this architecture on a GPU accelerator service provided by Kaggle. Integration with OpenCV. We perform real-time dehazing by using OpenCV. The original video is decomposed frame by frame, and then it is fed into the neural network that we have just defined. The dehazed frame from the neural network is then woven back into a video using OpenCV. The tech stack we are using mainly consists of TensorFlow and Keras, which we have used for building the model architecture, training and testing the deep learning model, and OpenCV for video inference and for pre-processing the video frames and post-processing the video frames. We have used NumPy and Pandas to pre-process the datasets that we have downloaded from Kaggle. We plan on deploying this model in a quantized state provided by TensorFlow quantization library, which usually takes the developed neural network model and performs the operation of quantization, that is reducing the unnecessary layers and data type representation, and which usually results in a model with a low amount of space and faster model. We have also developed a pruned model of the neural network, which is also a low space representation of the original model using the TensorFlow library itself. The quantized and the pruned model are helpful in deploying the neural network for inference on specialized hardware such as Raspberry Pi or FPGA implementation of dehazing algorithm. We believe this quantized and pruned model will be better used along with the GPU accelerated hardware, as this can severely impact the frame rate per second of the processed video. Thank you.